Subtitle: Stop MAC flooding and DHCP exhaustion with switchport controls. Duration target: 12-15 minutes. You plug a laptop into an open switchport in the office. Nothing unusual, right? But what if that laptop is actually sending thousands of fake MAC addresses into the switch, filling up its address table until it starts flooding every frame everywhere? Now an attacker, sitting on that same port, can sniff all your network traffic. This is a MAC flooding attack, and it exploits one of the most basic behaviors in Ethernet switching. Switches learn unlimited MAC addresses on every port by default. Port Security is Cisco's built-in defense against this exact problem. It limits how many MAC addresses a switch port will accept and defines what happens when someone tries to exceed that limit. Let's walk through how it works, from the attacks it prevents to every configuration option you need for the CCNA. Before we configure anything, understand what Port Security is defending against. Two attacks share the same weapon: spoofed MAC addresses. First, DHCP exhaustion. An attacker sends thousands of DHCP discover messages with different fake source MACs. The DHCP server runs out of addresses, legitimate devices can't get IPs, and the switch's MAC table fills up as a side effect. Second, MAC flooding. The attacker directly floods frames with spoofed source MACs until the switch's entire address table is full. Once that happens, any frame destined for an unknown MAC floods out every port in the VLAN. The attacker's port receives copies of everything, breaking confidentiality completely. Port Security stops both by limiting how many MAC addresses any single port can learn, and taking action when the limit is breached. Enabling Port Security starts with one command, but there's a catch. The switchport Port Security command will be rejected if the port is still in dynamic mode. That's DTP negotiating, not explicitly set to access or trunk. So first you lock the port mode with switchport mode access, then enable Port Security on top of it. That's two commands minimum. Set the port as access, then enable security. By default, this allows exactly one MAC address on that port, and error disables the port if a second shows up. Verify with Show Port Security interface, which tells you whether Port Security is active, the maximum MAC count, how many are currently learned, and which address was most recently seen. When Port Security triggers a violation, the default response is shutdown mode. It error disables the entire port. The port goes down completely. All traffic stops both ways, and dynamically learned MAC addresses on that port are forgotten. You see secure shutdown status in Show Port Security interface output. The violation counter increments to 1, and critically, the total MAC addresses count resets to 0. The last source address field still shows which MAC address caused the violation. That's your evidence for troubleshooting. To bring the port back, you do shutdown, then no shutdown on the interface, but only after fixing whatever triggered it. If an attacker is still connected, the port just error disables again immediately. ErrDisable recovery automates that re-enable process without manual intervention. It's disabled by default, but configurable per cause, meaning you can enable it for port security violations while keeping BPDU guard or power policing ports manual. Enable it with ErrDisable recovery, cause psecure-violation in global config mode, and the switch will automatically re-enable error-disabled ports after a timer. Default is 300 seconds, 5 minutes. You can change that interval with ErrDisable. Recovery interval followed by the number of seconds. Check status with Show ErrDisable recovery, which lists all causes and whether each has auto recovery enabled. The key thing to remember: ErrDisable recovery only re-enables the port. it doesn't fix whatever caused the violation in the first place. So, if a rogue device is still connected, the port will cycle between enabled and error-disabled states every 5 minutes. One MAC address per port is the default, but real networks need flexibility. A switch-to-switch uplink connects multiple downstream hosts. You might set the maximum to 8 with switchport port security maximum 8. An IP phone connected through to a PC has 2 MAC addresses, so you set the maximum to 2. The command is switchport port security maximum, followed by your number, and both dynamic and static secure MAC addresses count toward this limit. So if you statically configure one address, only the remaining number of dynamic slots are available on that port. Use Show Port Security to see a summary across all ports. Maximum allowed, currently learned, count for each. So far, we've been letting the switch learn MAC addresses dynamically, but Port Security also lets you specify exactly which devices are allowed on a port. Static secure MAC addresses are manually configured with switchport port security MAC address, followed by the address in dot notation. They're stored in both the MAC table and running config, persisting across port downs. You can mix static and dynamic on the same port. For example, statically lock in an IP phone's MAC address while allowing a PC to learn dynamically on the same access port. For voice VLAN specifically, add VLAN voice at the end of the static MAC command, so it's tied to that VLAN context. View all secure addresses with Show Port Security Address. This is better than the generic MAC table command because it tells you whether each was secure configured or secure dynamic. Shutdown mode error disables the entire port, which is secure but sometimes too extreme, especially for critical servers. Port Security gives you 2 alternative violation modes: Restrict and Protect, configured with switchport Port Security Violation Mode. Restrict keeps the port up, but discards violating frames while logging each one via syslog and SNMP traps, and incrementing the violation counter. Protect does almost the same thing. Port stays up, violating frames are dropped silently, with no log messages and no counter increment. The practical difference? Restrict gives you visibility into violations so you can respond, while Protect is truly silent. Protect mode isn't recommended because a violation without notification means you're flying blind about what's happening on your network. Restrict is the compromise. When shutdown feels too harsh, but you still want to know something's wrong. By default, secure MAC addresses don't age out. The aging time is 0 minutes. That means once a port learns its maximum secure MACs, those addresses stick forever as long as the port stays up. To enable aging on a per-port basis, use switchport with their port security aging time, followed by minutes, for example 5. This frees up slots when devices disconnect and reconnect over time, creating a balance between security control and operational flexibility. But aging behavior has 2 types. Absolute is the default, meaning once learned, a secure MAC address starts its aging timer and gets removed when it expires, even if the switch keeps receiving frames from that MAC. The address is locked to a fixed lifetime, regardless of activity. Inactivity mode resets the aging timer each time it receives a frame from that MAC, behaving like regular dynamic addresses. Switch between them with switchport, port security, aging type, followed by absolute or inactivity on the interface. Sticky secure MAC addresses are a middle ground between dynamic and static. They're learned dynamically like regular secure MACs, but automatically written into the running config so they survive a port down. Enable them with switchport, port security, MAC address sticky on the interface. This converts all current and future dynamically learned addresses to sticky. The key benefit: if a port goes down, the MAC address list is preserved and reapplied when it comes back up. without sticky, dynamic secure addresses, are lost on port down, and the port relearns from scratch, which means someone could swap out a device while it's down and get through. Sticky addresses cannot be aged out, so they're permanent until manually removed, or sticky learning is disabled with the no form of the command. Port security sits on one side of a balancing scale, security versus operational flexibility. Shutdown mode and static MACs are maximum control but can disrupt legitimate traffic if someone plugs in a laptop with virtual machines that generate multiple MACs. Restrict mode and dynamic learning are more forgiving, but give attackers a foothold if they're only partially blocked. Sticky addresses automate the admin work of static configuration, but lock you into whatever address was first learned on a port. The CCNA exam focuses mainly on implementation, knowing which commands do what and how the 3 violation modes differ. But in real networks, you'll design these policies based on what's actually connected to each port and how much risk your organization tolerates.